2 a day. All right. You will need your calculator out if you don't have it on your desk. Michael. Oh, it's really cute. No. Everybody has their calculator? All right, so today we're going to graph polynomials, these curve functions, using the x-intercepts. And we're going to look at those x-intercepts and kind of just talk about what they mean and then how we can graph them. Most of the problems that you'll be given are already in factored form. Yay, you don't have to factor them. But if it is in factored form, then we would do a little bit of factoring to find the x-intercepts. So on Wednesday, we talked about a polynomial having this crazy form, and Ava said, do you have to memorize that? And I said, no. A polynomial we know should be descending in order from the largest power. And what has to happen with the exponents of polynomials, or what can't they be? Chris? They can't be negative. What else can't they be? All right, the x can't be as an exponent because then it's exponential. Nick, what else? Fraction or decimal. So pretty much they have to be nice whole numbers, 2, 3, 4, 5, 6, 1. Could even be a 1. So underneath there are 4 terms here, and these 4 terms we've used most of the year. And the goal is to recognize that these statements are really the same. The term is the same. So they would be synonyms of each other, trying to pull in that little English word. But they all represent the same thing. I might just write the answer a little differently. So it says, if k is a real number, then the following statements are equivalent, equal, the same. So a 0, something is a 0 of a polynomial when it is written in a certain way. And when we say x equals k, when our function is equal to 0, we're finding a 0 of the polynomial. So when the function is equal to 0 and essentially you solve, you're finding a 0. And again, k could be 5, it could be 10, it could be negative 3. It's an answer. It's a number. How is a factor different from a 0? So how would you write a factor? How does a factor usually get written? So think about when you factor, what do your answers look like when you factor? Eden?
Maybe it would be like x outside the parentheses, and then there'd be a parenthesis like k minus 1.
You're so close. I'm just going to place that x in the parentheses and put the k with it. So a factor is like x plus 1, x minus 3, x minus 7, x plus 10. That's a factor. A factor gives me a 0. I use a factor to find a 0. But really, they're kind of the same thing. I use one to find the other. A solution is the same thing as a 0. Is a solution when f of x equals 0, which happens when the f of x equals 0. So those guys are really the same. A 0 is a solution is a 0. You might be asked to solve and find the zeros, or it might just say solve the polynomial. Or it could say find the zeros of a polynomial. You're factoring it to get those answers. The last part is an x-intercept. An x-intercept is just written slightly differently, and you can kind of cheat by reading the rest of the sentence. An x-intercept is written as an ordered pair. So instead of saying x equals an x-intercept, k is an x-intercept if it is written as k comma 0. An x-intercept is a point on the x-axis. It's the same thing as the solution for x. It's the same thing as a 0 for x. They all mean the same thing. You're just writing it a little differently. So if it says to factor, I should have an answer in parentheses. If it says to find an x-intercept, I should have an answer as a point. And if it says to find a solution or a zero, then my answer should be an x equals 4. But essentially, we're finding all the same information.
So for the zeros, we don't write like comma zero.
Nope, you would just write x equals 5, x equals 10, x equals 20. Only time we write it as an actual intercept or as a point is when it's an intercept. Other questions? You're going to go through those same 4 terms next year, chapter 2, section 3. Trig and pre-calc. So we kind of talk about them again and again and again just to solidify the process. So we have use x-intercepts to graph the polynomial. And that's pretty much how we graph polynomials. We look at x-intercepts, we look at end behavior, and then we're also going to see if we can find max and mins. But important parts of the graph would be where it crosses the x-axis. Where does the graph go? Does it go up, does it go down? So here it says use the x-intercepts. We have 1/4 and then x plus 1 squared and x minus 1. So what would the zeros be of this function? So step number 1, use the x-intercepts. What are the zeros of the function, Jack?
-1 and 4.
And how do you get -1 and 4? I know it's a pretty obvious question, but how'd you get that? So really, if you're finding a zero, you're just setting each of those equal to 0, you're solving for x. So because -1 and 4 are the zeros, we're going to plot those 2 points as x-intercepts. So the zeros form an x-intercept of -1, 0, and it forms an x-intercept of 4, 0. So we're going to find the x-intercepts. The second step, it says plot points between and beyond the x-intercept. So instead of just picking the 5 points from -2 to +2, we're going to now choose some points that surround the x-intercepts. So if I have an x-intercept of -1, I'm picking -2 and 0 because it surrounds the x-intercepts. And then a couple other numbers in between, 1, 2, 3, 4 is an x-intercept, and then going beyond it to 5. So see if you can plug those numbers into your calculator and try and fill out this table to have some points that are in between the intercepts and beyond it. So pass it to the left, pass it to the right. Yes, sir.
I don't know how to plug this.
Just go into like your regular place to plug them in, the regular screen. So you just take 1/4 and then in parentheses, -2 plus 1 squared. You might be able to do it in your head. Nope, you didn't. Nope. Alright, so the first one at -2. Anybody have a number? Josh, do you have a number at -2? -3 halves, so we're -1.5. How about a 0, Josh? At 1? 2? Or -4.5? 3? And then at 5. Say again? 9. Okay, so 9 halves. Any questions with those? So it says determine the end behavior. So the next thing we're going to think about is the end behavior. Because f has blank factors, how many factors are there really up here? What would the degree be? How many factors are there? Josh? Why are there 3? Yeah. So we have x plus 1 twice, that are really 2 factors, and x minus 4. So there are 3 factors. So we have 3 factors and a constant factor of 1/4. That's the number in front. That would be our leading coefficient. Is it an even or an odd function if it has 3 factors? Odd. And the leading coefficient is positive or negative if it's 1/4. Positive. We're going to just write our end behavior a little different. So then the left side and the right side. I'm just trying to change that a little bit. So Peter, if it's odd and positive, the left side goes down and the right side goes up. So really that means my graph goes to negative infinity and my graph goes to positive infinity. That's what down and up means. So if the left's going down, it's to negative infinity. If the right's going up, it's to positive infinity. The last part, we're going to see if we can graph this now. So we're going to plot the points. We're going to graph the x-intercepts. We're going to graph the points in the t-chart. And then we're going to see if we can get the end behavior. So plot the points in your t-chart. Obviously, that last point's off our graph. So there are a good bit of points on here. If you play connect the dots, we know the end behavior, the last point, or the point on the left, is supposed to go down. Playing connect the dots, we're going to connect it to the next point and then curve. So we have our turning point. It has to turn again and then continue up, stretching up to that little point at the value of 9. 5, 9. The last thing on the side of it, after we have it graphed, we've got the end behavior, just ask for the domain and the range. Remember, domain is x and the range is y. So looking at the graph, how far does it stretch left and right? How far does it stretch up and down? So Ava, left and right, how far does it stretch left and right? Yeah, negative infinity to positive infinity. Every polynomial has that domain because you can have any number in for x. So every polynomial will have that same domain. And then Ava, if the left goes down and the right goes up, the range is also negative infinity to positive infinity. The range is easier to see because I know this side's going down, that side's going up forever to infinity. Questions? So we're going to see if we can graph the next one, hopefully a little quicker. So instead of all of the wording, I have a little sheet that we're going to follow as well for when we do the homework. Graph the following function by the process in the previous example. So list the x-intercepts. Write them as ordered pairs. We're going to get a little t-chart using a couple of values in between the x-intercepts and beyond the x-intercepts. And then we're going to list the end behavior. So Peter, what would the three x-intercepts be?
2, 0, -1, 0, and 1, 0.
Sometimes it helps if you graph those x-intercepts. So he said 2, 0, -1, 0, and then he also said +1, 0. Once you have them graphed, pick a couple of numbers to make a t-chart. If you prefer your t-chart to go vertically, then let it go vertically. It's up to you. But I want to pick a point that's beyond my intercepts. So I have a -1, 0, so I probably want to use -2. In between two x-intercepts, well, I have one at -1 and one at +1. In between my other two. Peter, what could I use in between 1 and 2? 1.5. And then beyond my last intercept would be a 3. So I don't have as many values that we're picking here. And then the end behavior would be the last thing that you're going to list to make sure that we have the graph ending in the correct location. And I have this little sheet here. This is to help us with the homework as well. It's just making sure that you do those steps to graph. So this is just the little directions to follow. Because the book just says to graph, and I want to make sure you're like getting the correct thought process when you're graphing. Numbers are going to be a little larger, so it'll be a little trickier to graph, but we'll make it work. Can anybody tell me what the end behavior would be? Peter? Yeah. So it's the same as the previous one because it's odd. There are 3 zeros. The number of zeros gives us also the end behavior of the power. There are 3 of them. There are 3 x's. My power would be odd. And then it's also positive. So I graphed, or I have the points here. -24. There's only so much space on your graph, so just plot it below. And then we have a point at that guy right there. And then it goes up to 0, 4, which we can plot. We have another intercept at 1. In between 1 and 2 at 1.5, there's a value at -1.3. And then at 3, we're going up to 16. Again, just make it go off your graph so you have something to connect to. So end behavior, the left side goes down. Just connecting my points. Mine looks pretty ugly up here. Turning and connecting up. Hopefully your graph looks a little nicer than mine. So Nina, the domain would be, and the range is also -∞ to infinity. So there's one final thing that we are going to talk about, and that's how we can use the calculator to help us find this lowest point or the highest point of the graph. And those are the two terms. I think there's two terms underneath this graph here. And it's called a local maximum or a local minimum. And they give you a picture to kind of get you to see that a local maximum or a local minimum is the highest for the max y value of a turning point. You can have more than one local max, and usually we just call it the maximum value. Because it's only based off of its turning point. So if I have a curve, the local max is the highest point of the curve. If I have 5 curves, I could have a couple of max values, the highest point of the turning point. The local min is then the lowest y value instead of the highest. Of the turning point or of the curve. And again, you can have more than one of those as well. So it might not be the highest because the highest point is going to be infinity if the graph goes to infinity. Or the lowest point is going to be negative infinity if the graph goes to negative infinity. But it's based off of the curve. So we're going to flip the page. Right here, there's one less turning point than the power. And whatever the power is, there are that many. Says if a polynomial has n distinct root zeros, then it has exactly n minus 1 turning points, which is what we summarized at the worksheet. I want us to just plug one of these into the calculator so you can see what we're looking for. So we're going to use the calculator. So if you take out your calculator and go to y equals, and you're going to plug in x cubed minus 4x squared plus 6. There's a function in the calculator that enables us to calculate the max and the min. And I just want to show you how we can do that. So if you graph x cubed minus 4x squared plus 6, we have a max and we have a min. Max is the highest point, the min is the lowest point of the curve. If you hit second and the trace button, which is also the calculate feature, and hit number 3, we're going to find the minimum value. That little blinking guy, the cursor, we need to trap the minimum in between two numbers. So it says left bound. Your little blinking cursor needs to be on the left side. So it looks like my minimum is right here. I just need to be somewhere to the left. Hit enter. And then I have a line, you might have an arrow. Right bound, the little blinking cursor needs to be to the right, somewhere on the right side. So my little blinking cursor now is somewhere on the right side of this lowest point. I'm going to hit enter. You either have 2 arrows or 2 lines, depending on what calculator you have. The last thing you do for guess is just hit enter. You never will do anything else with guess. And then it gives you the minimum point. Algebraically, there is no way for us to find that until you get to calculus. You will always be finding the lowest point of the graph or the highest point of the graph using the calculator. So if you know somebody in calculus, they might be able to say, hey, this is how you do it. But you don't have the skills to do that yet. is some graphing. 15, 17, and 19 are just looking at a graph and estimating the max or min. Anybody interested in doing 4 or 8, the graphs for 4 or 8 for Monday? Pull 4. Anybody like to do number 8?
Thank you.
Leah, you'll do 8? Awesome, thanks. Have a fantastic weekend.
Thank you. You too.
Really?
So you have to choose one of those functions. If you're finding a max, you have to use the max. If you're finding the min, you have to use the min. Does that make sense, Stephen?
Yeah. Thank you.
Mm-hmm.